I've been tearing down modern engines for years, and I keep seeing the same catastrophic damage pattern. Scored cam bearings, failed variable valve timing solenoids, piston ring failures from low-speed pre-ignition, and when I ask the owner what oil they've been running, the answer is almost always the same. I upgraded to 5W-30 for better protection. They thought thicker oil meant better protection. They were wrong, and it destroyed their engine. Today, I'm showing you the exact engineering reasons why using 5W-30 in a modern engine designed for 0W-20 is starving critical components of oil, causing timing system failures, and accelerating wear in ways that old-school mechanics never anticipated. This isn't about opinions or preferences. This is about how modern engines are fundamentally different from the V8s and inline sixes your father worked on, and why old-school logic is killing new-school engines. Let's get into it. Here's what changed in modern engine design that makes viscosity choice critical, and why the oil that worked perfectly in a 1995 engine will destroy a 2020 engine. Modern engines are built with dramatically tighter tolerances than engines from 20 or 30 years ago. Bearing clearances, piston-to-cylinder wall gaps, and oil passage dimensions have all shrunk as manufacturing precision improved. A typical modern four-cylinder engine has main bearing clearances of 0.0008 to 0.0015 inches, compared to 0.0015 to 0.0025 inches in older engines. That's a 40 to 50% reduction in clearance. Those tighter tolerances were designed specifically to work with low-viscosity oils like 0W-20 or 0W-16. The thinner oil flows through smaller clearances more easily, providing faster lubrication during cold starts and maintaining proper oil pressure with less pumping effort. The entire engine, bearings, oil pump, galleries, variable valve timing systems, is calibrated around the flow characteristics of 0W-20. When you pour 5W-30 into that engine, you're introducing oil that's too thick to flow properly through passages designed for thinner oil. And the consequences start immediately on every cold start. Here's what happens during a cold start with the wrong viscosity. Modern engines use variable displacement oil pumps that adjust output based on engine speed and oil pressure. These pumps are calibrated for 0W-20's flow characteristics. When you fill the engine with 5W-30, which is significantly thicker especially when cold, the oil pump has to work harder to push oil through the system. At startup temperatures, when oil is at its thickest, 5W-30 resists flow so much that the pump may not generate adequate pressure quickly enough to reach critical components. The variable valve timing system is one of the first casualties. VVT systems rely on precise oil pressure delivered through small passages to actuate cam phasers that adjust valve timing. These passages are sized for 0W-20's flow rate. When you use 5W-30, the thicker oil moves sluggishly through these passages, delaying pressure buildup and causing the VVT system to respond slowly or not at all. You'll get check engine lights for cam timing. Correlation faults. The computer commands a timing change, but the thick oil can't deliver pressure fast enough to make it happen. I've diagnosed dozens of failed VVT solenoids and cam phasers in engines where owners switch to 5W-30. The solenoids get stuck trying to move thick oil through tiny passages. The cam phasers wear prematurely because they're not getting oil pressure when they need it. The repairs cost $800 to $2,000, and they were completely preventable by using the correct viscosity. The cam bearings and main bearings are also starved during that critical first few seconds after startup. In a properly designed system with 0W-20, oil reaches the bearings within 1 to 2 seconds of cranking. With 5W-30, especially in cold weather, it can take 5 to 10 seconds for adequate oil pressure to build and reach all bearing surfaces. During those extra seconds, bearings are running dry or with minimal lubrication. That causes accelerated wear that accumulates over thousands of cold starts. I've torn down engines with only 60,000 to 80,000 miles that have severe bearing wear and scoring because the owner ran 5W-30 instead of 0W-20. The bearings show classic starvation patterns, worn more heavily at the edges where oil arrives last. This damage wouldn't have occurred with the correct viscosity. Now, let's address the myth that drives people to make this mistake. The belief that thicker oil provides better protection, especially under heat and load. This belief comes from old-school engine experience where thicker oil did provide better film strength in engines with loose tolerances and primitive oil chemistry. But modern oil technology has changed the equation completely. The critical measurement isn't cold viscosity, that's the 5W or 0W number. The critical measurement is HTHS, high temperature, high shear viscosity. HTHS measures the oil's ability to maintain a protective film under the exact conditions that matter most: high temperature and high mechanical stress. And here's what people don't understand. Modern 0W-20 oils from quality manufacturers have HTHS ratings that meet or exceed the protection levels of older 5W-30 formulations. AM Soil, Signature Series. 0W-20, for example, has an HTHS of 2.9 centipoise, which is higher than many 5W-30 oils from 15 years ago. Pennzoil Ultra Platinum. 0W-20 delivers similar high-temperature protection. These oils are engineered with advanced additive packages and synthetic base stocks that maintain film strength at operating temperature while flowing easily when cold. You get the protection where you need it, without the cold start flow restriction that damages components. The viscosity modifier technology in modern oils allows them to behave thin when cold for easy flow and thick when hot for protection. This is exactly what modern engines need: rapid lubrication at startup and strong film strength under load. Using 5W-30 gives you unnecessary thickness when cold, which hurts flow and delays lubrication, while providing no additional benefit at operating temperature because quality 0W-20 already delivers adequate HTHS protection. People upgrading to 5W-30 are solving a problem that doesn't exist while creating problems they don't anticipate. If you're concerned about protection under heat and load, the solution isn't thicker oil. It's higher quality oil in the correct viscosity. Switch from a cheap 0W-20 to a premium synthetic 0W-20 like AM Soil, Pennzoil, Ultra Platinum, or Mobile One, and you'll get superior protection without compromising flow characteristics. Now let's talk about the specific damage patterns I see in modern engines when people run the wrong viscosity. First is variable valve timing failure. I've already mentioned this, but it's worth emphasizing because it's so common and so expensive. Modern engines adjust valve timing constantly to optimize performance, fuel economy, and emissions. This requires precise oil pressure control through small passages and solenoids. Thick oil disrupts this system completely. I diagnosed a 2018 Honda CR-V with the 1.5-liter turbo that had multiple cam timing codes and rough running. The owner had switched to 5W-30 because his mechanic told him it would protect the turbo better. The thick oil couldn't flow through the VVT system properly. The cam phasers were sticking. The check engine light was on constantly. I drained the 5W-30, refilled with Honda's specified 0W-20, and the problem disappeared immediately. No parts needed, just the correct oil. Second is low-speed pre-ignition in turbocharged direct injection engines. LSPI is a destructive phenomenon where fuel-air mixture ignites prematurely during low RPM, high load conditions causing extreme cylinder pressure spikes that can crack pistons or damage rings. Modern 0W-20 oils are formulated with specific additive packages designed to minimize LSPI risk in these engines. When you substitute 5W-30, especially if it's not formulated for LSPI prevention, you increase the risk of this catastrophic failure mode. I've seen cracked pistons in turbocharged engines where owners used 5W-30 instead of the specified 0W-20. The oil contributed to LSP1 events that destroyed pistons under normal driving conditions. This is a $4,000 to $6,000 engine rebuild that was caused by using the wrong viscosity. Third is fuel dilution handling. Modern direct injection engines inherently allow some fuel to bypass the piston rings and contaminate the oil, especially during short trips and cold starts. This is a known characteristic of D1 technology. Modern 0W-20 oils are formulated to handle this fuel dilution with volatility specifications and additive packages designed to mitigate its effects. When you use 5W-30 that's not formulated for this application, the fuel dilution can cause the oil to thin excessively, lose protective properties, and break down faster. I've diagnosed severe oil consumption and ring wear in direct injection engines where owners used 5W-30 and drove primarily short trips. The combination of wrong viscosity and fuel dilution caused rapid oil degradation and accelerated wear. The correct 0W-20 formulation would have handled the fuel dilution much better. Fourth is cold weather starting damage. In cold climates, the viscosity difference between 5W-30 and 0W-20 becomes even more pronounced. At 0 degrees Fahrenheit, 5W-30 is significantly thicker than 0W-20. The oil pump struggles to circulate thick oil through the system. Critical components, cam lobes, rocker arms, turbo bearings, run dry or with minimal lubrication for extended periods during warm-up. I've torn down engines from cold climates where owners used 5W-30, and the cam lobe wear is shocking. The lobes are scored and pitted from repeated cold starts with inadequate lubrication. This damage is cumulative and irreversible. The engine loses power, develops valve train noise, and eventually needs a cylinder head replacement, all because the owner thought thicker oil was better. Fifth is oil pressure problems in variable displacement oil pump systems. Many modern engines use pumps that reduce output at idle and cruise to improve fuel economy. These systems are calibrated for 0W-20's flow characteristics. When you use 5W-30, the increased resistance can cause the pump to work harder than designed, potentially leading to premature pump wear or pressure fluctuations. I've diagnosed oil pressure sensor codes and actual low-pressure conditions in engines where the only variable was switching from 0W-20 to 5W-30. Here's the truth that old-school mechanics don't want to accept. Modern engines are not improved versions of old engines. They're fundamentally different machines with different lubrication requirements. The engineering decisions made in 1985 don't apply in 2025. Tighter tolerances, variable valve timing, direct injection, turbocharging, and advanced oil pump technology have changed what oil needs to do and how it needs to behave. When the manufacturer specifies 0W-20, that's not a suggestion or a cost-cutting measure or a marketing gimmick. It's an engineering requirement based on how the engine is designed and built. The bearing clearances, oil passages, VVT systems, and oil pump are all calibrated for that viscosity. Deviating from it causes problems. But here's where people get confused. They hear stories about older engines running forever on 10W-30 or 5W-30, and they assume that's because thick oil is inherently better. What they're missing is that those older engines were designed for those viscosities. The tolerances were looser, the oil passages were larger, the lubrication systems were simpler. Thick oil worked in those engines because those engines were built for it. Modern engines aren't. And forcing 5W-30 into a system designed for 0W-20 is like forcing the wrong size bearing into an engine. It might fit, but it's not going to work correctly, and it's going to cause damage. So what should you do if you're genuinely concerned about protection and you want to upgrade your oil? Don't change the viscosity, change the quality. Here's the safe way to get better protection without destroying your engine. First, stick with the manufacturer's specified viscosity. If your manual says 0W-20, use 0W-20, but upgrade to a premium full synthetic oil from a quality manufacturer. AM Soil. Signature Series 0W-20 is formulated with Group 4 PAO base stocks and provides exceptional protection under heat and stress while maintaining proper flow characteristics. Pennzoil Ultra Platinum 0W-20 uses gas-to-liquid base stock technology with excellent thermal stability and HTHS performance. Mobile One Extended Performance 0W-20 delivers strong protection with proven additive chemistry. These premium 0W-20 oils provide superior protection compared to cheap conventional or budget synthetic 0W-20 oils. You get better oxidation resistance, stronger film strength, superior thermal stability, and longer service life, all while maintaining the correct flow characteristics for your engine's design. Second, change your oil more frequently if you're concerned about protection. Running premium. 0W-20 synthetic and changing it every 5,000 to 6,000 miles gives you fresh additives and optimal protection throughout the interval. This is far more effective than using the wrong viscosity and hoping thicker oil compensates for extended drains. Third, if you're in extreme conditions, heavy towing, track use, extremely hot climates, consult your owner's manual for high temperature or severe service viscosity recommendations. Some manufacturers approve 5W-30 for specific extreme conditions, but only if explicitly stated. Don't make this decision based on internet forum advice or old-school mechanic opinions. Fourth, use oil that meets the latest API and manufacturer specifications. Look for oils certified for API SP or SP resource conserving, and make sure they meet any manufacturer-specific certifications like Dexos, ILSACGF6, or brand-specific approvals. These certifications ensure the oil is formulated for modern engine challenges like LSPI, fuel dilution, and turbocharger protection. Here's the bottom line. Using 5W-30 in a modern engine designed for 0W-20 starves critical components of oil during cold starts, causes variable valve timing system failures, increases risk of low-speed pre-ignition damage, and accelerates bearing wear from delayed lubrication. The belief that thicker oil provides better protection ignores modern oil chemistry and HTHS performance standards. Quality 0W-20 synthetic oils deliver equivalent or superior high-temperature protection compared to older 5W-30 formulations while maintaining the correct flow characteristics for modern engine designs. If you want better protection, upgrade the quality of your 0W-20, not the viscosity. Use premium synthetic 0W-20 from AMSoil, Pennzoil, Ultra Platinum, Mobil 1, or similar quality brands. Change it at conservative intervals. And trust the engineers who designed your engine to know what viscosity it needs. The 5W-30 upgrade isn't an upgrade at all. It's a guaranteed path to expensive repairs from VVT failures, bearing damage, and accelerated wear. Don't fall for old-school logic in new-school engines. What viscosity does your owner's manual specify, and are you running it or did you upgrade? Drop a comment with your vehicle and oil choice. And if this just saved you from destroying your engine with the wrong viscosity, hit that like button. Next week, I'm breaking down which modern engines are most vulnerable to wrong viscosity damage and showing you actual teardown photos proving what I've explained today. If you're not subscribed, hit that button now, drop a comment. I respond to everyone. Thanks for watching. I'll see you in the next one.